thanks everyone again for joining us today. Before we proceed with the talks, I want to take a moment to acknowledge the people who have, brought this workshop, have made this workshop possible, and also give you a sense of the theme, of the general theme of the workshop. I want to thank the Yale AI Initiative and the WUSI Institute, not for just funding the space, the facilities, but also the people. The staff, both at the WUSI and the Department of Psychology, has been incredibly helpful, fielding our last-minute requests with patience and care, including Kelly Rimole, Sue Amatredo, Kelly Tarka, Jenny Trujillo, and others. I also want to thank these graduate students here at Yale, Alap Shah, Daniel Kalbeck, Dangyu Gang, Mario Belladone, Yuteng Zhang, who are responsible, from everything, your name tags to, to our website. They really are running the workshop. So thank you guys. Now, the idea of this workshop came together within this initiative, PCC, which believe it or not, stands for Philosophical and Computational Foundations of Cognition, and it is at least at the faculty level comprised of these good people I was listing on my initial slide: Tyler Brooke Wilson, Bob Frank, Julian Harry Ettinger, Alex Le, Tom McCoy, Laurie Paul, myself, and Andre Vibinasa. A lot of those people will be speaking, and they will be among your ranks to mingle. But this is a multi-PI, multi-department interest group cutting across both departments and even Yale schools, with the partial goal of making Yale a really vibrant hub for issues related to computation and cognition, with weekly, monthly, and yearly programming. And to sign up for our mailing list to keep up with these things, you can scan that QR code or ask us about how to do it later on. Now, the goal of this workshop is to explore this challenge of what we call the efficiency gap. And the best way to illustrate what we mean by that is to look at one of the most impressive success stories of the field of AI, the self-driving cars. And specifically, we are going to be, thinking about the case of Waymo a little bit to make things, as concrete as possible, which operate nearly in 10 different large United States cities, are believed to be safer than humans in the way that they drive, and they, of course, continue to develop further. Now, we are going to think about the efficiency of the systems along these three core dimensions. The sensing capability, which is the sensors the car is equipped with to see its environment. The training data, which really makes up the intelligence of the systems. And wattage, or the rate of energy used, just the electricity, to train and use a self-driving car. And in the way we are going to do it, we are going to make a comparison to a typical learner. In this case, a garden variety high schooler who's just learning to drive, learning how to drive. Now, what do we mean by sensing capability? In the case of Waymo, this is the inputs to the system, right? So we are talking about, more than 10 superhuman cameras all around the car. So those are superhuman in the way their resolution work and in the way their night vision capabilities work. And multiple LiDARs, which are these essentially 3D scanners. Those are not available to you and I. Those are going to be able to detect very small things, and they are going to be able to know where things are in 3D. And these multiple 360 degrees radars, which keep up with the velocity and the distance of the nearby things, including the other cars. Now, the contrast becomes striking when you think about the human correspondence of this, right? Where we are talking about a pair of eyes, which are essentially, analog sensors, right? Your ganglion cells in your retina, which are just making measurements of luminance levels, and basically a rear view mirror, right, to be able to see the back. So that's kind of the sophistication of the tech, of the complexity of the sensing capability. So it's a striking contrast. And then when you go to training data, things get even more striking. Waymo is approximated to have about a century of nonstop driving experience, And this is kind of terabytes and terabytes of image data, but that's just the breadth of the training data. The depth of it is another world. This is a recent short documentary published in New York Times, about workers who are doing this labeling of the images that go into the training of the self-driving cars. And I'll let you just view it. There everything is just one image. Like the same image is being scrolled up and down. You can see the effort that went into kind of labeling each and every detailed corner and pixel of this image. And indeed, these workers approximate, a typical image is going to be half a day of effort of this sort of labeling. So really, the training set is this terabytes and terabytes of images, where each image is a half a day of human cognitive effort to label. So that's the breadth and the depth of the training data that goes into it. And again, it's a massive, massive contrast to what humans need to go through. So humans are estimated to kind of get by on about 20 to 50 hours of driving exercise experience to kind of pick up on driving. You may question the wisdom of letting a high schooler after about 20 hours of learning to get behind the wheels, but they will be fine. I mean, for all intents and purposes, they will be fine to drive on the highway or in their street. I'll not belabor the point, but a similar orders of magnitude difference of a contrast also runs for energy use, the rate of energy use, the wattage. So the overall picture then that comes from this is this incredible contrast, massive gap in the way humans can make intelligence, learning, perception, reasoning per unit sensing capability, unit training data, unit wattage, versus what you get for all of those things from the current state-of-the-art AI. Okay, so that's the efficiency gap. What explains it? You may say maybe it is evolution. I mean, we've, immortized a lot of this energy, throughout history, and maybe we are making kind of an apples to oranges comparison. Well, another perhaps less dodgy possibility is that we need maybe new algorithms for training artificial intelligence, or new architectures, or perhaps even, entirely different stacks, entirely different, kind of non-deep learning ways of thinking about what AI is like. Well, the honest answer is that we don't really know. And the reason, part of the reason we don't really know is that because not a lot of people are directly looking at this problem, and that's precisely the point of this workshop. So everyone, our speakers will talk about the work that they've been doing, not necessarily, directly focusing on the efficiency gap, but we think it is the kind of work that's really important to start thinking about this efficiency gap. And across the talks, the discussions, and the panels, we hope that at the end of this workshop, we will know a little bit more about the efficiency gap than we started with. All right, let me just briefly show you the program overview. We have, and this is the website. You can go and see more. We've kind of divided this into 4 rough sections of, planning and reasoning, learning and perception. These, sessions aren't meant to be boundaries, but kind of the average topic of that session. And at the end of each session, we have a discussion panel. And at the end of all workshop, we will have a general panel to kind of, convene and think about things that we have talked about.